Hello friends. In the previous video, we saw that the unit circle is just a circle of radius 1, and every angle on it gives you a point, where the x-coordinate is cos theta, and the y-coordinate is sine theta. So in this video, we're taking the next step. We're going to nail down the exact values for the most common angles you'll see again and again: 0, pi over 6, pi over 4, pi over 3, and pi over 2. And then we'll see how sin and cos behave across all four quadrants, where they're positive, where they're negative, and why. Once you know this, you can solve most trig problems in your head. No calculator, no memorizing endless tables. Just the circle. Let me break it down. Quick thing before we go further. You'll see angles written two ways. Sometimes in degrees, like 90 degrees. Sometimes in radians, like pi over 2. They're just two different units for the same thing, like measuring distance in miles or kilometers. The conversion is simple. A full trip around the circle is 360 degrees. The same trip in radians is 2 pi, so 180 degrees is pi. 90 degrees is pi over 2. And so on. So why bother with radians at all? Because once you get into calculus, formulas like the derivative of sine x become beautifully clean. But only when x is in radians. Degrees mess up the math, so mathematicians and engineers default to radians, and that's why your textbook is full of these pi fractions. Don't let the symbols intimidate you. Pi over 6 is just 30 degrees. Pi over 4 is 45. Pi over 3 is 60. Same angles, different language. Now let's look at what sine and cos actually equal at these angles. Alright, here are the 5 angles you'll meet over and over: 0, pi over 6, pi over 4, pi over 3, and pi over 2. Let's walk through them. At angle 0, you're sitting on the positive x-axis. The point is 1, 0. So cos of 0 is 1, and sine of 0 is 0. Makes sense. You haven't rotated yet, so you're at full horizontal distance and 0 vertical. At pi over 6, that's 30 degrees. The point is root 3 over 2, 1/2. So cos is root 3 over 2, sine is 1/2. At pi over 4, 45 degrees. The point is root 2 over 2 for both coordinates. This is the symmetric one. You're exactly between the x and y axis, so cos and sine are equal. At pi over 3, 60 degrees, the point flips to 1/2, root 3 over 2. Notice that it's the same two values as pi over 6, just swapped. And finally, at pi over 2, 90 degrees, you're sitting on the positive y-axis. The point is 0, 1. Cos is 0, sine is 1. 5 angles, 5 points. Now you might be looking at all those square roots and thinking, there's no way I'm memorizing this. Good news. There's a pattern that makes it almost automatic. Here's the trick. Watch what happens if I rewrite every value as the square root of something, divided by 2. At 0, sine is root 0 over 2. At pi over 6, sine is root 1 over 2. At pi over 4, sine is root 2 over 2. At pi over 3, sine is root 3 over 2. And at pi over 2, sine is root 4 over 2. See the pattern? As the angle goes up, the number under the square root goes 0, 1, 2, 3, 4. Just count up. And cos does the exact opposite. Starts at root 4 over 2 and counts back down: 4, 3, 2, 1, 0. Now simplify. Root 0 is 0. Root 1 is 1. Root 4 is 2. So you don't carry around weird square roots for those. They collapse into clean numbers. The middle 3, root 1, root 2, root 3, those stay as they are. So sine of 0 is 0 over 2, which is 0. Cos of 0 is 2 over 2, which is 1. Same values you saw before, but now you can rebuild them in your head in seconds. One pattern, 5 angles, both functions. That's the whole first quadrant locked in. Now let's see what happens when you go beyond 90 degrees and walk into the other 3 quadrants. Alright, so far everything's been in the first quadrant, the top right slice, where both x and y are positive. But angles can go all the way around the circle. So let's walk through what happens in the other 3. Here's the key idea, and this is why understanding cos and sin as coordinates pays off. Cos is just the x-coordinate of the point. Sin is just the y-coordinate. So the signs follow the geometry. Look at quadrant 1, top right. Both x and y are positive, so cos is positive, and sine is positive. Easy. Quadrant 2, top left. You're above the x-axis, so y is still positive. Sine stays positive. But you're to the left of the y-axis now, so x is negative. Cos goes negative. Quadrant 3, bottom left. You're below the x-axis and to the left of the y-axis. Both coordinates are negative, so cos is negative and sine is negative. And quadrant 4, bottom right. You're below the x-axis but back on the right side, so x is positive again. Cos is positive, but y is negative. Sine is negative. You don't have to memorize this. Just picture the point on the circle. Is it left of the y-axis? Cos is negative. Is it below the x-axis? Sin is negative. The geometry tells you the signs. Now there's one more idea that ties everything together, and this is what makes the whole circle workable from just 5 values. Okay, this is the part that ties everything together. Look at these 4 points, one in each quadrant. Each one is 30 degrees away from the nearest x-axis. That 30-degree gap is called the reference angle, the angle between the radius line and the x-axis. Now look at the coordinates. Quadrant 1, √3/2, 1/2. Quadrant 2, same numbers, but the x is negative. Quadrant 3, both negative. Quadrant 4, only the y is negative. See what's happening? The actual numbers, √3/2 and 1/2, are the same in all 4 quadrants. Only the signs change based on which quadrant you're in. So here's the workflow. To find sin or cos of any angle on the circle, say 210 degrees, you do 2 things. First, find the reference angle. 210 degrees is 30 degrees past 180, so the reference angle is 30 degrees. That tells you the magnitude, √3/2 and 1/2. Second, look at which quadrant you're in. 210 lands in quadrant 3, where both cos and sine are negative. So cos of 210 is negative √3/2, and sine of 210 is negative 1/2. Done! This is why those 5 first quadrant values are so powerful. Combined with the quadrant signs, they cover the entire circle. You're not memorizing 30 different angles. You're memorizing 5, plus a sine rule. Let's wrap this up. Alright, quick recap. Radians and degrees are just 2 ways to label the same angle. The 5 key first quadrant angles, 0, pi/6, pi/4, pi/3, and pi/2, give you the values you'll use 90% of the time. The √2 pattern makes them easy to rebuild from scratch. And once you combine those 5 values with the quadrant sine rules, you can find sine and cos for any angle on the circle. In the next video, we're going to take this circle and unroll it, turn it into the classic sine and cosine wave graphs. We'll see what amplitude, period, and phase actually mean, and why these wave shapes show up everywhere, in sound, in light, in electrical signals, in animation. The circle and the wave are the same thing, just drawn differently. If this video helped, hit like, subscribe, and I'll see you in the next one.